Now, what you need to know, which you guys probably already know, it's almost like one of those meetings that happens at work where, like, this meeting could have been an email. I did already give you this information, but I'm going to give it to you guys again. If you guys were taking the derivative of sine, you get cosine. If you're taking the derivative of cosine, you get negative sine. And if you guys wanted to see why, I have a really rad video for that where I walk through the proof of why that equals that. You can check it out. And what I do is I simply use a definition of the derivative as h is approaching 0. I have h on the bottom. On the top, we have x plus h. And f of x plus h and f of x. Okay, so let's do this. We're taking the derivative of g, and what we got here with g, we have two parts to it that are subtracting. And whenever you have two parts that are subtracting or adding, you can split them up and take the derivative of each of those individually. Like, we can take the derivative of negative 8x. Negative 8x, the derivative of negative 8x is negative 8. There's a couple reasons why. My favorite is the visual explanation. If I was graphing negative 8x, that would have a y-intercept of 0. And so it would start right here, and it would go down 8, right 1, up 8, left 1. And this would be your line. And if it's a line, my stews, at every single point, what is the slope at every single point on this line? It's negative 8. It doesn't change. It's always negative 8. So if you took the derivative of negative 8x, you would just get negative 8. It's a constant. It's always negative 8. All right, next, we have our cosine. What's the derivative of cosine? Negative sine. So we have negative sine x. Negative sine is positive sine, and so that one's done. And that's your answer. It doesn't matter if you put the sine x first or you put the negative 8 second. They're the same.